In this example, we're going to use factoring to solve. So I have two examples here. Let's start with cosine x sine x equals 3 cosine x. Before I start solving, look at the directions. The directions say find all solutions, but it gives me a specific interval this time. This time our interval is between 0 and 2 pi, which means I'm only looking at those values listed on our unit circle. It includes 0, but it does not include 2 pi. So if I have a point that is at the very end of the circle, we're going to use the value 0 instead of the value 2 pi. Let's look at the first question here. A, cosine x sine x equals 3 cosine x. So in order for factoring to work, we have to have it equal to 0. So I am going to move this 3 cosine x to the other side. Once I move 3 cosine x to the other side, we'll have this cosine x sine x minus 3 cosine x equals 0. To factor this, we have stuff in common. We have this cosine in both terms. So we're going to factor that out. So if I pull out that cosine, I'm going to be left with a sine x, a minus, and a 3. Now to finish solving, since now it's factored, we can separate them. So we have cosine x equals 0, and we have sine x minus 3 equals 0. If I solve this, I'm going to use my unit circle. I'm going to look for where cosine equals 0. So we go to our unit circle. Cosine is the x value. Cosine is 1, not 0, not 0. Right here, 0 at pi over 2. So my first solution for this side is going to be x equals pi over 2. Now let's see if we can find another one. Keep going around our circle, looking for where cosine is 0. Still haven't found it. Still looking. Here it is, 0. And that happens at 3 pi over 2, directly across from that top one we found earlier. So that's my second solution, 3 pi over 2. Now let's look at this sine part. I'm going to get sine by itself by adding 3 to both sides. So we get sine x equals 3. Now, I don't know if you remember, but back when we talked about inverse functions and we were looking up these values on our unit circle, we talked about the domain and the range of sine and cosine. Remember that sine and cosine are restricted by our unit circle for these questions. So it is not plausible that sine could ever be equal to anything bigger than 1 or smaller than -1 because we are limited by that radius of our unit circle, which is 1. So since we can never be equal to 3, this side of my equation doesn't yield an answer or a solution. The only solutions, therefore, are pi over 2 and 3 pi over 2. Now let's look at the second one, b. b is a little bit different. b is what we call, the format it's in is what we call quadratic form. So I have cosine to the 4th power x plus cosine to the 2nd power x minus 2 equals 0. Now in Algebra 2, you learned about u substitution, and you would use u substitution to rewrite things so that it looked more like a quadratic equation. So on this one, you can use u substitution if you'd like. I'm going to go ahead and just factor it. So we look at this first term, cosine to the 4th power. Cosine to the 4th power is cosine squared times cosine squared. Then we look at the last term, 2. The factors of 2 are 2 times 1. The middle needs to be positive, so I'm going to make this bigger number positive and the smaller negative. Once we have it factored, we separate our two equations. So we have cosine squared x plus 2 equals 0, and we have cosine squared x minus 1 equals 0. Let's solve them. Minus 2 from both sides. We get cosine squared x equals negative 2. Take the square root, and we run into a problem. The square root of negative 2 is imaginary. That means it doesn't exist. So this piece of our equation does not yield a solution. Let's move on to the second piece. Add 1 to both sides, and we get cosine squared x equals 1. Take the square root, because it's squared, and we're going to get cosine x equals plus or minus 1. So we're looking for where cosine is either positive 1 or negative 1. So let's look at our unit circle. Cosine is the x value, so right here, 1, and that's at the value, the angle 0. So our first solution here is going to be 0, because 0 is included. And then we work our way around the circle looking for negative 1, which is right here, negative 1, and that happens at pi. So my solution is also going to be at pi. And I'm just going to check and make sure it's not negative 1 or positive 1 anywhere else. It happens again at 0 and 2 pi, but we're not going to include 2 pi because of what I said earlier. This parenthesis means that it goes up to 2 pi, but it doesn't include it. So that's it. My solutions are going to be 0 and pi.